नमस्कार. आज आपण वेक्टरच्या प्रॉडक्टबद्दल बोलणार आहोत. There are two types of products in vectors, and these two types of products you have studied them in 11th standard physics. Now we'll revise these two concepts. First is called scalar product. What is scalar product? How it is defined? The scalar product of two non-zero vectors a bar and b bar is denoted by a bar dot b bar and is defined as a bar dot b bar is equal to magnitude of a bar into magnitude of b bar into cos theta. Now what is this theta? Theta is the angle between a bar and b bar. We may read this as a bar dot b bar is equal to a into b into cos theta, or simply ab cos theta. Now we can write this formula as cos theta is equal to a bar dot b bar upon ab. So cos theta is equal to a bar dot b bar upon ab, or magnitude of a bar into magnitude of b bar. So using this formula we can find angle between two vectors a bar and b bar, but for that we have to find their dot product and their magnitudes. We can write this as theta is equal to cos inverse of this dot product a dot b divided by product of their magnitudes. Okay, so this was about scalar product of two vectors. I will first explain all the terms and then we will solve problems. पहिल्यांदा मी सगळ्या डेफिनेशन जे आहेत ते डेफिनेशन तुम्हाला सांगतो, आणि हे डेफिनेशन सांगून झाल्यानंतर मी सर्व आर्टिकलवरचे प्रॉब्लेम घेणार आहे. तर आता ह्या स्केलर प्रोडक्टची डेफिनेशन सांगितल्यानंतर मी त्याच्या काही प्रॉपर्टीजबद्दल बोलणार आहे. समजा आपल्याकडे हे आय जे के हे पॉझिटिव्ह डायरेक्शन कॉर्डिनेट ॲक्सेसचे पॉझिटिव्ह डायरेक्शनने असणारे युनिट व्हेक्टर्स आहेत. सो व्हॉट इज आय डॉट आय? आय डॉट आय बाय डेफिनेशन इट इज मॅग्निट्यूड ऑफ आय विच इज 1 into cos of angle between them. Angle between them is 0. Cos 0 is 1, so I dot I is equal to 1. Similarly, J dot J is equal to 1. K dot K is equal to 1. Now what about I dot J? I dot J by definition, this is magnitude of first vector into magnitude of second vector into cosine ratio of angle between them. We know angle between I and J is 90 degree. So I dot J and cos 90 degree is 0. Cos 90 degree is 0. So 1 into cos 90, 1 into 0, which is equal to 0. J into K, J dot K is also 0. K dot I is also 0. So of these three unit vectors I, J, K, if we take dot product with itself, it is 1, and if we take dot product with any other vector, that is 0. Now if we find we note one thing, that dot product is commutative, so I dot J is 0 and J dot I is also 0. Now how to write the scalar product of vectors a bar and b bar when a bar and b bar are given in Cartesian form? Now Cartesian form of vector means when vector is expressed in terms of I, j, k. So if a bar is equal to a1i, a2j, a3k, b bar is b1i, b2j, b3k, then a bar dot b bar, their dot product. Now here we assume that dot product distributes over addition. So a1 into b1 I dot I. I dot I is 1. So A1 into B1 into 1. Simply we write it as A1 into B1. A1 into B2 into I dot J. I dot J is 0. I dot K is also 0. So when we multiply these three vectors by A1I, of these three, only one remains non-zero. Other two becomes 0. Now we take this A2J and multiply each of these three vectors in second bracket by A2J. J dot I is 0. J dot J is 1. So A2B2 will come here, and A2B3 its coefficient is 0. So that will vanish. Similarly, while multiplying by A3K, we observe that only one product, that is A3B3, will come in picture. So this is dot product of A bar and B bar. When components of A bar are A1, A2, A3, components of B bar are B1, B2, B3, then their dot product is A1, B1 plus A2, B2 plus A3, B3. Here it is A1, B1 plus A2, B2 plus A3, B3. So this is the dot product of A bar and B bar. If I take this value of A bar dot B bar and go to the formula for cos theta is A bar dot B bar upon AB. And if I put this value here, this formula will take this form. So this is, we can use this Cartesian form. This is called Cartesian form of the dot product. We can use this Cartesian form of dot product for finding angle between two vectors. So after explaining all the definitions, I will come to the problem. पहिल्यांदा मी हे सगळ्या टर्म एक्सप्लेन करून घेतो आणि हे समजल्यानंतर आपण प्रॉब्लेमकडे वळणार आहोत. आता एक कन्सेप्ट सांगणार आहे मी, त्याला प्रोजेक्शन्स असं म्हणतात. म्हणजे जर माझ्याकडे एखादी लाईन असेल, इफ आय हॅव अ लाईन अँड अ पॉइंट, when I draw perpendicular from that point, the foot of the perpendicular is called projection. If I have a segment, say AB is a segment, I have a segment. If I draw perpendicular from point B, perpendicular from point A, if I draw perpendicular from point B, perpendicular from point A, and if I name these points as P and Q, then this segment PQ is called projection of segment AB on this line L. If I name this as line L, then this segment PQ is called the projection of AB. Now if I have a vector instead of segment AB, if I have a vector here, this is vector. If I name this vector as B bar, and if I have vector along this line, and if this vector is A bar, then we can ask what is projection of B bar on A bar. Suppose this is vector B bar and this is vector A bar. हा एक vector आहे B bar आणि दुसरा vector आहे A bar. What is projection of B bar on A bar? So if we draw perpendicular, already one point is common here. Then this length is the projection of B bar on A bar, and we can prove that this projection, which is projection of B bar on A bar, we can show that projection of B bar on A bar is equal to A bar dot B bar upon magnitude of A. So if we have to assume that this angle is theta, use definition of cos theta, and we can obtain this result. Okay, so this is about the scalar projection. scalar projection of vector b bar on vector a bar is given by a bar dot b bar upon magnitude of vector a bar. Similarly, we define concept of vector projection. Vector projection of b bar on a bar is defined as the scalar projection multiplied by a cap. What is a cap? A cap is unit vector along a bar. Now similar to this, we can ask question, what is projection of a bar on b bar? Scalar projection of a bar on b bar is defined as their dot product divided by magnitude of b bar. Vector projection of a bar on b bar, a bar dot b bar upon magnitude of b bar into b cap. So we have to make respective changes. Okay, so this was about projection. Then after projection, we move to define one term. This term is direction angles and direction cosines. In plane geometry, two-dimensional geometry, we have studied concept of inclination of a line, slope of a line. So this concept is a little bit similar to the inclination of line. First we define direction angles of a vector. So let me draw one figure here. Suppose these are coordinate axes. X axis, y axis, z axis, these are coordinate axes. Suppose this is x axis, this is y axis, and this is z axis. And if I draw a line, this is line. Let us consider vector OA bar. Consider a vector OA bar. Now why I am considering vector? Because it has specific direction. Now I can ask question, what angle this vector OA makes with x-axis? What angle this vector makes with y-axis? Positive direction of x-axis, positive direction of y-axis. Angle made by this vector with positive direction of z-axis. Angle made by this vector with positive direction of x-axis. These angles made by a vector with positive directions of coordinate axes, these angles are called direction angles. Here I will read the definition. The direction angles of a non-zero vector a bar are angles alpha, beta, gamma that a bar makes with the positive x, y and z axis respectively. म्हणजे त्या वेक्टरने कोऑर्डिनेट ॲक्सिसच्या पॉझिटिव्ह डायरेक्शन बरोबर केलेले जे अँगल असतात त्या अँगलला म्हणायचं डायरेक्शन अँगल्स. मग जर समजा मी युनिट वेक्टर आय घेतला, इफ आय टेक युनिट वेक्टर आय, what angle that I makes with x-axis? 0 degree angle. What angle unit vector I makes with positive y-axis? 90 degree. What angle that I makes with z-axis? 90 degree. So what are the direction angles of unit vector I? 0 degree, 90 degree, 90 degree. 0 degree, 90 degree, 90 degree are direction angles of vector I. Now we define another term. That term is direction cosines. So what are direction cosines? Here is the definition. the cosines means cosine ratio, the cosines of these direction angles, that is cosine ratio of angle alpha, I read it as cos alpha, cos beta, cos gamma, are called the direction cosines of vector A bar. So if direction angles of a vector are alpha, beta, gamma, then cos alpha, cos beta, cos gamma are called the direction cosines. And in short, we read this word direction cosines as DCS. We read this as DCS. Okay, so this was about direction cosines. So let me ask you one question. What are direction angles of I? What are direction angles of unit vector I? And I have answered this question. 0 degree, 90 degree, 90 degree. Now my question is, what are direction cosines of I? What are direction cosines of I? Cos 0 degree, cos 90 degree, cos 90 degree. Cos 0 degree is 1. Cos 0 degree is 1. So 1, 0, 0 are direction cosines of the unit vector I. What are direction cosines of J? 0, 1, 0 will be the direction cosines of unit vector J. Similarly, we can ask question, what are the direction cosines of unit vector K? And answer is 0, 0, 1. Okay, so this was about direction cosines. Now next definition is direction ratios. Now here is the figure. We are going to extend this concept from vector to line. So if we have line has no specific direction, so we can consider this direction of line or this one. So direction angles of a line, direction angles of a line depends on in which direction we consider that line. म्हणजे ती लाईन आपण कोणत्या डायरेक्शनने विचारात घेतलेली आहे त्यानुसार त्या लाईनचे डायरेक्शन अँगल्स ठरतात. किंवा दुसऱ्या भाषेमध्ये सांगायचं झालं तर एकाच लाईनला डायरेक्शन अँगलचे 2 सेट असतात. एकाच लाईन करता डायरेक्शन अँगलचे 2 सेट असतात. मी ह्या फिगरमध्ये दाखवलेलं आहे. पॉझिटिव्ह एक्स ॲक्सिस बरोबर OL ह्या व्हेक्टरने अल्फा अँगल केलेला आहे. पॉझिटिव्ह वाय ॲक्सिस बरोबर OL डॅश ह्या लाईनने पाय मायनस अल्फा हा अँगल केलेला आहे. मग जर आपण LL डॅश ह्या लाईनचे डायरेक्शन अँगल्स विचारले तर त्याच्यामध्ये अल्फा घ्यायचा का पाय मायनस अल्फा घ्यायचा, तर 2 सेट असतात. देर आर 2 sets of direction angles which are associated with every line. Okay, if line doesn't pass through origin, then how to find its direction angles? We draw another line parallel to that line and which passes through origin, and then we can measure angles. Now I am going to define a term which is called direction ratios. So let me explain what are direction ratios. So before moving to direction ratio, let us obtain a relation between direction cosines. We have to obtain relation between direction cosine. We know cosine ratios of direction angles are called direction cosines. So this need as alpha is the angle between unit vector I along x-axis and vector a bar. I am assuming that direction angles of vector a bar are alpha, beta, gamma. So if direction angles of vector a bar are alpha, beta, gamma, alpha is angle made by a bar with x-axis. Means angle between a bar and I is alpha. So cos alpha is equal to a bar dot I upon product of their magnitudes. So, okay. So cos alpha is equal to, if I simplify this, I get cos alpha is equal to a1 upon magnitude of a bar. Similarly, cos beta is equal to a2 upon magnitude of a bar. Cos gamma is equal to a3 upon magnitude of a bar. Now what is magnitude of a bar? If this is a bar, then magnitude of a bar is root of a1 square plus a2 square plus a3 square. Now by squaring and adding, कशाला स्क्वेअर करायचं आणि ॲड करायचं? हा कॉस अल्फाची व्हॅल्यू, कॉस बीटाची व्हॅल्यू आणि कॉस गॅमाची व्हॅल्यू. If we square them and add, we get cos square alpha plus cos square beta plus cos square gamma is equal to sum of the squares of these three quantities. If we simplify this, we will come to know that this sum is 1. So this is relation between direction cosines of a line. म्हणजे एखाद्या लाईनचे डायरेक्शन कोसाइन cos alpha, cos beta, cos gamma असतील तर त्यांच्या वर्गांची बेरीज ही नेहमी 1 असते. सम ऑफ द स्क्वेअर्स ऑफ DCS of any line is always equal to 1. Generally, we denote these direction cosines by letters L, M, N. आपण त्याला L, M आणि N हे अक्षर वापरणार आहोत. So sum of their squares means L square plus M square plus N square. L square plus M square plus N square is equal to 1. L square plus M square plus N square is equal to 1. This is relation between direction cosines. Okay. Now this vector a bar is a1i plus a2j plus a3k, and this a1 is equal to a cos alpha. In previous slide we have seen this cos alpha is equal to a1 upon a. I read this magnitude of a bar as a. So a1 is equal to this a into cos alpha. a1 is equal to a into cos alpha. a2 is equal to a into cos beta, and a3 is equal to a into cos gamma. So I will take this a common. Cos alpha I plus cos beta j plus cos gamma k, cos alpha a I plus cos beta j plus cos gamma k is equal to this a bar in left side divided by its magnitude. So a bar upon its magnitude is equal to cos alpha I plus cos beta j plus cos gamma k. But this a bar upon a is a cap. When we divide vector by its own magnitude, we get unit vector along that vector. So unit vector along a bar is cos alpha I plus cos beta j plus cos gamma k. So if we have a vector and we are asked to find direction cosines of that vector, simply we have to find a cap, that is unit vector along the given vector, and in that unit vector coefficients of ijk are direction cosines of that vector. Okay. Now after defining direction cosines and relation between them, I will define third term. It is called direction ratios. What are direction ratios? Let me read the definition first. Any three numbers which are proportional to direction cosines of the line are called direction ratios of the line. Any three numbers which are proportional to DCS are called DRS. डायरेक्शन कोसाइन्सच्या प्रमाणात असणाऱ्या कोणत्याही तीन नंबरला डायरेक्शन रेशो म्हणतात. हो, कोणतेही तीन नंबर जे डायरेक्शन कोसाइनच्या प्रमाणात असतील. आता प्रमाणात असतील म्हणजे काय? व्हॉट इज मीन बाय नंबर्स आर इन प्रपोर्शन? Numbers are said to be in proportion if their ratio is constant. Same multiples of DCS. So if L, M, N are direction cosines and A, B, C are direction ratios, then these A, B, C are multiples of L, M, N. म्हणजे डायरेक्शन कोसाइनच्या पटीत असणाऱ्या संख्या घ्यायच्या, मल्टिपल्स. सो A is equal to lambda into L, B is equal to lambda into M, C is equal to lambda into N for some lambda, real number lambda. So can I take lambda is equal to 2? Yes, yes. So if L, M, N are direction cosines, 2L, 2M, 2N are direction ratios. Can I take lambda is equal to -3? Yes, you can take. Can I take lambda is equal to 0? No, 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 no. Non-zero real number. Some non-zero real number. Okay. Can I take lambda is equal to 1? Yes. If I take lambda is equal to 1, then ABC will be equal to LMN. चालते की. इथे एक एक्झाम्पल दिलेलं आहे. इफ डायरेक्शन कोसाइन्स ऑफ अ लाईन आर 0, हाफ √3/2. Then if I multiply them by 2 into 0, 0, 2 into half is 1, and 2 multiplied by √3/2, that is √3. So these are direction ratios. If I multiply each of them by √3, 0 into √3 is 0, 1 into √3 is √3, and √3 into √3 is 3. So 0, √3, 3 are direction ratios of the same line. एकाच लाईनचे डायरेक्शन रेशो आपण वेगवेगळ्या पद्धतीने लिहू शकतो. डायरेक्शन रेशोज आर नॉट युनिक, दे आर मल्टिपल्स. ओके, देन we have defined direction cosines, direction ratios. Now what is relation between direction ratios and direction cosines? Let me read this. Let A, B, C be direction ratios and L, M, N be direction cosines of a line. Then by definition we have these elements are proportional to ABC. So L upon A is equal to M upon B is equal to N upon C, and suppose this ratio is lambda. So L is equal to A lambda, M is equal to B lambda, N is equal to C into lambda. But we have proved this relation L square plus M square plus N square is equal to 1. So A square lambda square plus B square lambda square plus C square lambda square is equal to 1. We take that lambda square common, find the value of lambda and put this value of lambda here. So we get L is equal to A into lambda, but we have value of lambda. So we get relation between L, M, N and A, B, C. So if we know values of A, B, C, we can find values of L, M, N. जर आपल्याला डायरेक्शन रेशो माहिती असतील तर त्यावरून आपण डायरेक्शन कोसाइन काढू शकतो. ठीक आहे. आता एक्झाम्पलला सुरुवात झालेली आहे. मी एक प्रॉब्लेम तुम्हाला करून दाखवतो. फाइंड A bar dot B bar. If magnitude of A bar is 3, magnitude of B bar is √6, and the angle between A bar and B bar is 45 degree. By definition, A bar dot B bar is equal to magnitude of A bar into magnitude of B bar into cosine ratio of angle between them. हे दिलेल्या गोष्टी आहेत. 3 √6 into cosine ratio of angle between them. Cos 45 degree is 1 upon √2. √6 can be read as √3 into √2. √2 will get cancelled. and after simplifying we get answer 3 root 3. So a bar dot b bar is equal to 3 root 3. मी ह्या एक्झाम्पल बरोबर इथं थांबतोय. उद्याच्या तासामध्ये आपण ह्या प्रॉडक्टवरचे आणखी काही एक्झाम्पल पाहणार आहोत आणि स्केलर प्रॉडक्ट नंतर पुढचा जो प्रॉडक्ट आहे फॅक्टर प्रॉडक्ट, त्या फॅक्टर प्रॉडक्टबद्दलची सुद्धा माहिती घेणार आहोत. थांबूयात, भेटू उद्या.